Welcome to our lesson on machine learning. In this lesson, we will explore what machine learning is, how it works, and the different types of machine learning. Machine learning is a subfield of artificial intelligence that focuses on the development of algorithms and statistical models that can learn and improve from experience without being explicitly programmed. In other words, machine learning algorithms use data to learn and improve their performance rather than being told exactly what to do. To train a machine learning model, we need to feed it with a dataset that includes examples of inputs and their corresponding outputs. The model then learns the relationship between the inputs and outputs and can make predictions on new data. There are two main types of machine learning: supervised learning and unsupervised learning. In supervised learning, the dataset includes labeled examples, which means that the inputs are paired with their corresponding outputs. The model learns from this labeled data to make predictions on new, unlabeled data. In unsupervised learning, the dataset does not include labeled examples. The model must find patterns and relationships in the data on its own. Machine learning algorithms are designed to automatically learn patterns in data and use that information to make predictions or decisions. These algorithms can be categorized in many ways, but one common categorization is based on the type of output they produce. Regression and classification algorithms are two common types of machine learning algorithms. Regression algorithms are used when the output is a continuous variable. This means that the output can take on any value within a certain range. For example, in a real estate application, a regression algorithm might be used to predict the price of a house based on its size, number of bedrooms, and location. The output of the algorithm would be a predicted price, which could be any value within a certain range. Classification algorithms, on the other hand, are used when the output is a categorical variable. This means that the output can only take on a limited number of values or categories. For example, in a medical application, a classification algorithm might be used to predict whether a patient has a certain disease based on their symptoms and medical history. The output of the algorithm would be a prediction of whether the patient has the disease or not, which is a categorical variable with two possible values, positive or negative. Some examples of regression algorithms include linear regression, polynomial regression, and logistic regression. Linear regression is a simple algorithm that predicts a continuous output based on a linear relationship between the input variables and the output. Polynomial regression is a more complex algorithm that can capture non-linear relationships between the input variables and the output. Logistic regression is a classification algorithm that predicts a binary output based on a logistic function of the input variables. Some examples of classification algorithms include decision trees, support vector machines, SVMs, and artificial neural networks. Decision trees are a simple algorithm that splits the input data into smaller subsets based on a series of if-then statements. SVM are a more complex algorithm that separates the input data into different categories using a hyperplane. Artificial neural networks are a very powerful and flexible algorithm based on human brain mechanisms that can capture complex relationships between the input variables and the output. In summary, machine learning algorithms can be categorized as either regression or classification algorithms based on the type of output they produce. Regression algorithms predict a continuous output, while classification algorithms predict a categorical output. Different types of algorithms are suited to different types of problems, and the choice of algorithm depends on the nature of the data and the problem at hand. That's it for our lesson on machine learning. In the next lesson, we'll explore some specific applications of machine learning in more detail.